Hello, pre-algebra friends. Y'all make fun of me for saying that, but you are my pre-algebra friends. So I will say hello to you and welcome to 6.4. This is a little bit different. This note system is a little bit different. I actually took the notes from the teacher's guide instead of making them up myself because of all the geometry figures. So I need you to turn to page 300 in your book. You can pause the video and go get your book if you need to, but I need for you to see the vocab words on page 300 and the book as we go along. So the two vocab words are similar figures and corresponding parts at the top of page 300. I kind of wonder if I were to ask you what it means when you hear two things are similar. If you have a similar house as your friend, you drive a similar car, what that means to you. To me, it means that they're alike in some ways, but not exactly alike. And in math, that's the way similar figures, that's the same definition for similar figures. If two math figures are similar, they have the same shape, you can see right here, but they're not necessarily the same size. One is a mini-me, one's a big one, and one's a small one. There's a special symbol that we use, and here it is right here. It's like an upside-down S that indicates that two figures are similar. The sides and the corresponding parts that have the same relative position are not necessarily the same because one side is longer than the other, but we are going to talk about corresponding parts of similar figures. Two figures are congruent, meaning the same, absolutely the same, if they have exactly the same shape and the same size, meaning you could cut one out and put it and it would fit exactly inside the other figure. So we've got congruent figures and we've got similar figures. Congruent figures are exactly the same. Similar figures have the same relative shape, but they are not the same size. So let's look at how some of these problems set up. So if you are given a similarity, which is noted by this symbol right here, between two triangles, here are the triangles ABC and DEF, they have corresponding angles and they have corresponding sides. And the way that you know what corresponds with what without even looking at the picture, you could even hide these pictures, is the way these alphabetic letters are listed. So A is listed first, that's angle A right there, and his corresponding angle is angle D because it's listed first in the second triangle. B, angle B, is corresponding to angle E because they're listed second, and that leaves, of course, angle C going with angle F. So here are the pairs that we just talked about. And the same thing with the sides. If you look at side AB, those are the first two alphabetic letters that are listed. They are corresponding to side DE. So there's AB, and he corresponds with DE, and similarly the other two pairs of sides can be listed as well. So the way that the similarity is listed is really important, and you don't even need the pictures if you have the letters listed for you. So there's an example down here, example number 1. It gives you the similarity between these two, what is this, a pentagon, 1, 2, 3, 4, 5, two pentagons. So will you go ahead and list the corresponding angles and the corresponding pairs of sides that go together based on the order of the alphabetic listing? So this is how we identify the corresponding parts of similar figures. Which angles go together? Which sides go together? The second part of it is actually finding the ratio of corresponding side lengths. So obviously, these side lengths are not the same. One is much smaller than the other, but all of these side lengths have the same ratio. So the way this sets up is you look at side AB, and he goes with GH. So AB is 6, and GH is 2. And that reduces to 3/1. So the ratio of all of these side lengths is 3 to 1. So let me show you what it looks like if you were to pick another pair of sides to find the, to see if your ratio really is 3 to 1 for all of these. So let's pick CD, these two right here. They go with JK. So CD, his corresponding side is JK. If we go pluck the numbers from our two figures, CD is right here. He's 5.1. And JK down here, and the smaller guy is right there. He's 1.7. So if we compare this ratio, if we get rid of the decimals so that we can really look at the fraction, we multiply the numerator by 10, we get 51. We multiply the denominator by 10, we get 17. And 51 divided by 17 happens to be 3 over 1. And this will be the same with every single pair of sides that you do. You will end up with the same ratio, 3 to 1. So that is a property of similar figures. And you can see the properties of similar figures in your textbook in the big green box in the middle of page 300. Two things are true if you have similar figures, if you're looking at page 300. Number one, your angles of your similar figures are the same measure, and we call that congruent. The angles are congruent. The corresponding angles are congruent. The corresponding sides are in the same ratio. You can be taking this note, and you can also make a note that it's on page 300 in the middle of the page. Okay, let's keep going. Next page, just a little bit more practice with talking about similar figures. It gives you, and now instead of listing triangle ABC similar to KLJ or whatever, it shows you the relationship with these little bitty marks. So angle A with one little arc goes with angle J. Angle A is congruent, and that's the symbol for congruent, an equal sign with the little similar sign over it. He goes with angle T. Angle B has two little arcs. He goes with angle K. And the last one, of course, is angle C. And he is congruent to the guy with three marks, angle L. So those are the angles that are congruent, and they tell you all of this right here. And now we have to decide if the ratios of the corresponding sides are equal. So we know all the angles are equal, but these guys aren't similar unless their ratios are all the same. So AB, side AB, goes with side JK. How do I know? Because it's the side that's between the one arc and the two arcs, just like it is over here. So here's the relationship. AB, JK, BC, KL, AC, JL. What we have to figure out if these are all the same ratio. So you plug in the numbers, and apparently they hop on a calculator and turn them into decimals, and they all turn out to be 0.625. So we can say that, yes, definitively, we know that these two triangles are similar because the corresponding angles are actually the same measure, and the ratios are, the ratio of the lengths of the corresponding sides all turn out to be 0.625. So those two things you have to determine in order to tell whether two figures are similar or not. Okay, let's look at this example. Let's see if I've got this guy on my page. Okay, so basically it's asking you now to find the measure of an angle. Find, well, no, this is the side length, sorry. Find the side length of segment GH, this guy right here, and also the measure of angle K. Well, the first thing that we look at is this guy right here. They give us the similarity. So finding the measure of angle K, which is right here, is just as easy as going to look at what's the measure of his corresponding angle, which is angle S, this guy right here. So he's the same measure. So angle K is 64.7 degrees, just like his buddy angle S. Okay? Now we need to look at the ratio of the corresponding sides. So we've already taken care of part B. Now we know we look at the corresponding side for GH. GH, first two listed here, so his corresponding buddy is PQ. There it is right here. Oh, and they tell us these aren't similar. Actually, these figures are congruent, which means they're exactly the same. If you cut one out, you could put it right on top of the other. So all we have to do is go see how long is PQ. PQ right here is 4, so GH is 4. So we're dealing here with congruent figures. We've also talked about similar figures. So you have to read these instructions really closely to tell whether you're looking for congruent, exactly the same figures, or are you looking for ones that are just similar. Okay, let's run through this example number 2 really quick. If these two rectangles are similar, then they have the two things they need to have in common. All of their angles, the corresponding angles, need to be congruent. And all of the corresponding sides need to have the same ratio. Now, obviously, the corresponding sides aren't all the same length. You can tell this guy's a little bitty compared to that guy. But we can check all of the angles. And in a rectangle, what are all the angles in a rectangle? Now, I hope you're saying 90 degrees. So we know all of these angles are the same measure. So that's one step. We know that all of the corresponding angles are congruent. Now we just need to look at the ratios. So they give us the similarity right here. So you need to check the ratio of EF. He goes with AB. You need to check the ratio of GH going with CD. GH is the last two. CD is the last two. And the other two pair are EH and AD. FG and BC. So if you go plug in these numbers, and what do we know about a rectangle? We know this side is 10, and this side is 3, and this side is 5, and this side is 1. When you plug in all these numbers, do you get the same ratio? And I want to know what it is. So we'll talk about that in class. All right, and the last one, they tell us that these two triangles are congruent, meaning they are exactly the same. If you were to cut one out, it would fit perfectly over the other one. So simply they're just asking us, well, how long is TU? How long is this guy? And what is the measure of angle N? Well, all we have to do is look at his mirror triangle. Angle N goes with angle T. Angle T is 20 degrees, so angle N is also 20 degrees. Let's see, what are we trying to find? TU. Who does he go with? He's the last two over here, so the last two over here are NP. NP is 9.4, so this guy is also 9.4. So you guys have some work to do in the textbook, a few homework problems in the textbook, and then we'll talk about it in class when I see you next. Bye-bye. Thanks for watching.